Now let's look at another type of question. Let's look at another type of question. Here we have to prove that vector A plus B, the magnitude of vector A plus B whole thing square is equals to modulus of A whole thing square plus 2 A dot vector B plus modulus of B whole thing square. How can we do this? Well, I can rewrite this. Okay, I can rewrite this as, well, let's take LHS for sure. LHS first. So LHS is given as this. So this can be rewritten as A plus B into A plus B. We can rewrite it like that. Why? We know A into A is equals to modulus of A whole thing square. I'm just reversing the process. That's all. And now I can actually apply the scalar properties. So that will give me A into A plus A into B plus B dot A plus B dot B. Surprise, surprise, A dot A will give me A whole thing square plus here I will have 2A dot B. Why? We know A dot B is equals to B dot A. This is another property of scale product. So that will be equals to B squared. And yeah, the question is completed. Now let's do this one. They're asking us to prove again, but in this case, the question is a little bit different. But we are going to do the same thing. We are starting from left-hand side. Okay, so here we have in the left-hand side, this is equals to, we can rewrite it. How? A plus B into A plus B. And similarly, this can be rewritten as A minus B into A minus B. And this will give me A into A plus A into B plus B into A plus B into B plus A into A minus A into B minus B into A. Minus into minus will be plus, so I will get plus B into B. And this will give me A into A will give me modulus of A whole thing square plus 2AB plus B modulus of B whole thing square plus A whole thing square minus 2AB plus B whole thing square. Now these two can be cancelled and we will be left with 2 modulus of A whole thing square plus 2 modulus of B square. And this is how you have to tackle this specific question. Let's try and solve this question. The points A and B have position vectors -2, 4, -4 and 6, 8, 0 respectively. Point C has position vector -1, K, 0 and O be the origin. Find in terms of K, OA dot OC and then we have to find OB dot OC. Second question, they have given that AOC is equals to BOC and we have to show that K is equal to 7. Calculate the area of triangle is there, but we are not going to do that now because it's related to vector product of two vectors. So we are not going to focus on that. We're just going to focus on dot product now. Okay, so let's start with OA dot OC. So we have to find, first of all, we will find OA dot OC. Okay, so before I do this, let's just take a minute to visualize these things. So we have OA, we have OB, and we have OC. I'm not exactly sure whether this is the exact points of OA, OB, and OC. Okay, but I'm just randomly drawing 3 vectors OA, OB, OC so that it will be easy for me to do the question. Okay, so we know OA into OC will be equals to, since the question gives us OA is equals to -2, 4, -4, OA is given as -2, 4, -4, and OB is given as 680 and OC is given as minus 1 K 0. So OA dot OC will be equals to minus 2 into minus 1 plus 4 into K minus 4 into 0. So that will be equals to plus 2 plus 4K. So I can write down it as 2 plus 4K. And OB into OC is also, we have to find that also. So OB into OC will be equals to 6 into minus 1 plus 8 into K plus 0 into 0, which will give me minus 6 plus 8K. Okay. And they are saying in the question, AOC is equals to BOC. They are saying AOC is equals to BOC, which means this is AOC, this is AOC, and this is BOC in this diagram. But is it correct? No, it's not correct. The diagram is inaccurate. Why? AOC should be equals to BOC. All right. So C must be somewhere here. C must be somewhere here. I don't know exactly where, but I can say that these C will bisect, equally bisect the angle AOB. So if this is X, they are saying this angle is also X. So instead of using X, I'm going to say this equals to theta. Okay, this is equals to theta. All right. So now, since AOC is equals to BOC, okay, I can say we can apply the other scalar product equation. We can apply the other scalar product equation, which states that A into B is equals to modulus of A into modulus of B cos theta. Okay. And since we are speaking about angle here, okay, I can say cos theta is equals to A into B over modulus of A into modulus of B. All right. That's fine. Okay. So here I'm going to replace every single vector. Okay. So I know cos theta in OA and OC's story, I can say cos theta is equals to OA dot OC over modulus of OA into modulus of OC. Okay, I'm just replacing the values. That's all. And similarly, I can say cos theta is equals to, in OB and OC story, cos theta is equals to OB. I can say this is equals to theta. Let obviously let let AOC is equals to BOC is equals to theta. So OB dot OC over modulus of OB into modulus of OC. Okay. So here we know OA dot OC is equals to 2 plus 4K. 2 plus 4K over modulus of OA into modulus of OC. And here I know OB dot OC, vector OB dot vector OC is equals to minus 6 plus 8K over OB dot OC. So we can modulus of OB dot modulus of OC. I mean, I'm multiplying actually. Okay. This is the thing I can come up with. Now I can equate these two since theta is equal, cos theta will be equal to each other. So I can say 2 plus 4K over modulus of OA into modulus of OC is equals to minus 6 plus 8K over OB modulus of OB into modulus of OC. Okay. And I can cut out OC. Obviously, I can cut OC out. So I will do that. OC, OC, cancel. So I will be left with this. But we can find the modulus of OA. We can find modulus of OA. Okay, we can find the modulus of OA. OA, magnitude of OA is equal to square root of 4 plus 16 plus 16, which is equals to 6. And modulus of OB is equals to square root of 36 plus 64, which is equals to 10. So here we can rewrite it as 2 plus 4K over 6 is equals to minus 6 plus 8K over 10. Hereafter, it's just simple simplification. Okay, it's just simplification. I will, should I have to erase this? Yeah, I will erase all this. Okay, I will erase all this. Okay, and now I can simplify this. 2 plus 4k into 10 will be equals to 6 into minus 6 plus 8k. So 20 plus 40k is equal to minus 36 plus 8k. So 56 is equals to 48k. Not 8k, 48k. This is 48k. So 56 is equals to 8k. So k will be equals to 7. This is what we have to prove. So how can we do this question? They're saying vector u is equals to minus 3i plus j plus k. So it's always better to write any vector in its numerical form so that we can easily tackle those questions. So u is equals to minus 3, 1, 1. Okay. And they're saying vector v is equals to mj plus nk. So they're saying v is equals to mj plus nk. Well, this means 0i plus mj plus nk. That's what this means. Yeah, that's what this means. So I can write that down also in its numerical form and I will get 0mn. And they have given that vector v is a unit vector. What is the meaning of unit vector? Well, if a vector is a unit vector, the magnitude of the vector is equals to 1. So magnitude of v is equals to 1, which means absolute value of v is equals to 1. And we know how to find the absolute value of a vector. That is equals to v1 square root of v1 square plus v2 square plus v3 square. Okay, so this is equals to, I can say 0 square plus m square plus n square. And that is equals to 1. So 1 is equals to 0 plus m square plus n square. Okay, because I'm squaring both sides. So I will get 1 is equals to m square plus n square. Okay, well, this is done. This is one equation that we have come up with. Then they are saying the vector v is perpendicular to u. Okay, so we know if two vectors are perpendicular to each other, the dot product between them will be equals to 0. Why? The angle between them is equals to 90 degrees. Okay, if u is perpendicular to v, we can say the angle between them is equals to 90 degrees. So the dot product must be 0. Okay, so we'll find the dot product here. Minus 3 into 0. Okay, so we have to find u dot v. Minus 3 into 0 is equals to 0 plus 1 into m is equals to m and 1 into n is equals to n. So we get u dot v is equals to m plus n, which is equals to 0. So I can say m is equals to negative n. And I can replace that here. Okay, this is the second equation that I have come up with. This is the first equation that I have come up with. So I can replace, okay, I can replace sub m is equals to negative n, okay, in 1. And that will give me 1 is equals to n square. Actually, negative n whole thing square is also n square. So n square plus n square, which is equals to 2n square. So n square is equals to 1 over 2. So n will be equals to plus or minus 1 over square root of 2. This is what I will get. So I can rewrite this as plus or minus 2, square root 2 over 2. Yeah, that's also possible. That's not a wrong way of interpretation. I'm just rationalizing the denominator. So now I know there are two values for n, and I know that negative n is equals to m. So I can say if n is equals to square root of 2 over 2, m will be equals to negative square root of 2 over 2. If n is equals to negative square root of 2 over 2, m will be equals to square root of 2 over 2. So there are two values for m and n. And what is the question? Find the possible values of m and of n. And that's how you have to do this question. Simple one. Just apply what you know, and yeah, you will be done in no time. Thanks for watching the 10th video in our vector series. If you found these dot product practice questions helpful, don't forget to like, share, and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master vectors and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.